Hello, ladies and gentlemen. Good morning. Bonjour à tous.
Good morning, ladies and gentlemen. Welcome to this very important day, which is indeed a very important day for manned spaceflight, for the European Space Agency, and of course for this center, the launch of this service module, one of the main elements of the International Space Station. In just under 20 minutes, we can expect this launch with original videos from Baikonur. And we will right now have a link with a representative at the Russian Control Center, the SUB near Moscow, who is Jochen Graf. Good morning, Jochen. Can you hear me?
Good morning, Thomas. Good morning, everybody from the Russian mission. Good morning, everybody from the Russian Mission Control Center, SUB in Moscow. We are here in the space station control room, which is the first time in full use for this program. What you see in front of you is the big screen. Very important on the right side in yellow, the countdown clock. It is now 19 minutes and 43 seconds before liftoff. In the center, you see the status of the countdown as it is proceeding. Important that 2 hours and 10 minutes before liftoff, the data management system has been switched off. We have confirmation that all 6 computers are fully up and running. Temperature has been stabilized and everything is okay concerning the data management system. We have the thermal control system has been switched on. The service tower has been removed, as you have seen. And important, at L-45 minutes, the automatic launch sequence has been initiated. And we are now waiting at 14 minutes before liftoff, the arming of the fairing separation system. The control room here is fully manned, as you can see. Since about 2 hours ago, people have been coming in to work here. And we have also a dedicated console, which you can see, which is reserved for the European agency and contractor staff, and they monitor the performance of the data management system and of the service module.
Jochen, thank you very much for this first report. So everything is on track, and we are really expecting this important event in about 19 minutes.
Today it's really important for the International Space Station. Service module is a living quarters, so it actually becomes a real space station in 2 weeks when docked. With me here, the director of manned spaceflight, Jörg Förster-Böhel. This is an important moment for European involvement in this stage and for this center too. Could you give some comments?
Of course, first of all, that is an important moment for the International Space Station community. We have been looking forward a long time to that important launch event of the service module Swesda, which will be launched in a few minutes, hopefully. And that, as you correctly say, is already making the space station first operational tool in a few months from now on. Of course, we will have to continue our assembly sequence, but with the service module, we are really achieving a major milestone. The most important day is, of course, for the Russians. With the service module Swesda, they are delivering their key element to the International Space Station. But I would not like to neglect that also for us here in Europe, it is an extremely important day. The service module plays an important role for our deliveries and for our future operations. We have on board, as you already heard, the data management system, which is a sort of central computer of this important module. The Swesda will house also in a few years from now the European robotic arm, which will operate on board of Swesda. We will actually also dock our ATV, our automatic transfer vehicle, to the service module. That is our most important contribution to the operations of the International Space Station. And finally, I would like to also mention that we are using very soon the service module as an experiment module. You will hear later on more about this, but we have already 2 important experiments on board of Swesda that will fly up today. One is a commercial experiment and the other one is a scientific experiment, which will already open for us the possibility to make experiments on board of that module. Last but not least, of course, the day today is first also for our Erasmus User Center here in Holland. We are transmitting for the first time live pictures of a launch of the International Space Station. And as everybody knows, there are many more to come, and I hope this center will also qualify as such a station.
Thank you very much, Mr. Feustel-Büchel. Now, ladies and gentlemen, you know that the International Space Station is a huge construction. It has approximately 1.5 times the size of a football field. Maybe this is a good moment to look back about the assembly that has been taken place till now. The launch of the FGB took place approximately 1.5 years ago on the 20th of November 1998, and only a few weeks later the Node 1 Unity module was launched with the shuttle, as you can see at the moment in the video clip we prepared for you. Here you see already the preparation of the service module, which is getting ready for launch in the assembly building in Kazakhstan. And this is the docking which will take place in approximately 2 weeks.
So we are really at the very early stage of the assembly, and some more 40 flights will be needed. So let's look maybe, have a look to this Swesda model.
Let's just start on this right corner here. You see little cabinets on this side. I just step into it. Now, imagine this is a sleeping room, less than a square meter of place, but in weightlessness, it doesn't actually matter. You can place your sleeping bags on the wall or on the ceiling. If we come out here, we see a big table, and this is the place not only where the crew takes its meals, but also where a lot of work will be done, a lot of experiments, because this table can be used to strap down standalone experiments. Behind this wall, you have the water recovery system in order to prepare the food and, of course, to provide drinking water to the crew. And we just go around here.
To the atmosphere, maybe?
Oh, yes. You see here 2 of these silver assemblies. Those are oxygen generators, part of the life support systems, which also are placed behind your backlody in these walls.
There is 2 kinds of
yes, we have these emergency oxygen supply systems, which are loaded with chemical cartridges. They are placed in here, and we have an electrolysis system. So we continue in this direction. Behind the wall here, by the way, you have the drives for the solar arrays who are providing the electricity for the station. And here you see a lot of control panels. This is the central control post of the service module. This post, for example, is used for remote controlling the docking of the Progress transport vehicles, or, if needed, the approach of the FGB, which is already in orbit. And finally, on my right side, you see the central warning panel, and most important for us at the moment, there are 2 places for laptops, which are the interface to the central computer system of the service module, which is, of course, for us a very important piece of equipment. These computer systems, it's consisting of a lot of different computers, are actually placed on the wall, which would be on this side. And this is what we probably look a little bit more into detail right now.
Yes, I think we will have some video to try to see a little bit the integration and construction of the ESA module in Moscow, and also the DMSR that will be integrated.
Okay, here we have an external view of the service module. You can see as the technicians are crawling in and preparing everything for the launch. This is already in the assembly building in Baikonur. A last view on the DMSR as it is stored inside the service module. And here you have a view from the laboratory. This is one of the laptops which interfaces to the DMSR with a home page, the so-called home page, from which the cosmonauts can call up all the function. And this is the system itself, the DMSR, and I think it's quite remarkable that this processor technology is the most advanced at the moment on board the space station. Even on the American segment, the processors, or most of the processors used there, are a little bit older, about 10 years, and that goes back on a development about 6 years old.
Okay, I'm now with Stefan Grohr. Good morning.
Good morning, Claudia.
So you in Atrium were building the DMSR. Tell us a little bit about the role, the function. It has been referred even as the brain of the space station. Is it an exaggeration?
Yes, it is the brain of the space station, and the real test of this brain I think we will have in the night of the 24th, 26th or 27th, when the docking procedure will come, when this module will be docked with the configuration just in orbit. And then these FTCs, failure tolerant computers, and all the DMSR system will be in operation. And that's the real test of the software, which is behind these small boxes you can see here.
It's a particular
and
approach.
That's really the brain, and that will be the test. And it's really exciting for us that we have delivered this system in 1998. Our engineers at home in Bremen and Toulouse have developed this fault-tolerant computer and data management system since 1959.
And for 10 years lifetime on board the
For 10 years
station.
lifetime, and that is one of the real topics. We produce and develop a key element, a software avionics system for the total station, not only for the assembly sequence, but also for the operation sequence. And the challenge is to operate the system more than 10 years. And for that, we have to standardize the system. We have to maintain the system more than 10 years. And for software, it's a real challenge. You know, the cycle is 2 years, 3 years, and then new software will coming up.
Because this also will be used for other items at the space station, for ATV and...
Here it will be used, and that's the standardization process of this software and computers. The first use is within the DMSR. The second is in the ATV, and some elements of this system are active then in the Columbus system.
Columbus too.
We try to sell that even to the Americans. They have some problems by American. Even I think European systems are the best when we are talking about this software system. You ask for the task of this software, so we have to control the attitude of the full station. We have to control the data and the management flow, and even this system will be active when the European robotic arm, for example, is in operation to assembly the Russian part of the space station. So it's the full scenario of the total station, which is in this brain and this heart of the station.
And this brain has been built in Western Germany.
Western Germany is gone. It has been built in Germany and in Toulouse, in Astrium, and the system design was in Bremen. A big contribution was in Toulouse, and both are now fitted in the new company Astrium in this integrated team. And I have great confidence that we are ready to operate the system by this company, by this good staffing and good engineering from Bremen and from Toulouse.
Okay, thank you very much, Mr. Graul, for this explanation of the DMSR. Now, ladies and gentlemen, we are again linked with Jochen Graf in Zug to hear about the latest developments in the Russian Control Center. Jochen, can you give us an update, please?
Yes, we are back here from the control center, 6 minutes and 25 seconds and counting. We have in the meantime had the arming of the fairing separation system has taken place. The important thing, the service module has switched to internal power at 9 minutes before liftoff, and we are waiting for the important 5 minute before liftoff launcher readiness signal.
Okay, super. Jochen, I will come back to you in a moment, and we just would like to get also an update from our control room here with Roland Lütgen. Roland, can you give us also a little update?
Yes, Thomas, this is Roland. We are following the last activities of the service module launch preparation. We've received telemetry from the service module up to about 2 minutes ago. We are waiting for the service module telemetry recorders to be activated, and looks like everything is ready for launch.
Well, wonderful. Thank you very much. Now, ladies and gentlemen, I have with me Mr. Mark Heppner, who has the overall responsibility for the space station utilization and the microgravity promotion. Good day, Mr. Heppner.
Hello, Thomas.
I think this is also a very important day for you, huh?
Absolutely. Apart from that, this is a very important step in assembling the space station. It is also a very important step for the scientists who look forward to using the space station for their research. And already with this launch, you will see that soon after you will have one experiment from Europe, which is now black body, which is used for studying the health of astronauts when they are doing research on the external side of the station. Later on, you will also see that the research will focus on health which is applicable on Earth. You will see that research will be focusing on, for example, osteoporosis, which is a big health problem on Earth. You will see research focusing on cardiovascular problems of the equilibrium system. And all these type of things are really already in proposals that we have right now, and they will be executed later on when the space station is in assembly.
Mark, how was the response to the announcement of opportunities for the scientific community in Europe?
Well, this was very much above expectations. We have issued now 3 announcements of opportunities, 1 for the use of the space station at the external locations, and 2 for what you can do inside. And we have received several hundreds of proposals from all over Europe, really too much ever to accommodate. So we have applied strict criteria in principle on the scientific sense, but we have also received, and this is something which we really like, proposals from industry who want to do research in applications. They want to use the station in looking, for example, for cleaner combustion processes in cars or in power plants on Earth.
Okay. So thank you very much for the moment, Mark. I think we don't have to be worried about the scientific participation in that and the utilization.
Absolutely.
Thank you very much for the moment. Now, as we are closing up to launch, ladies and gentlemen, it's something like 3 minutes left. Let's again switch over to Jochen Graf at ZUP and hear about the latest preparations at the control center. Jochen, how are things going there?
Yes, I'm here. Are we on?
Yes, we can hear you, Jochen.
The launcher has given its readiness signal. We are waiting in 45 seconds that also the service module gives its final launch readiness signal. Important is then the launcher is fully on automatic countdown. About 2.5 seconds before liftoff, the Proton rocket switches to internal power, at which point in time there will also be the ignition signal to the main engines, and 1.6 seconds before liftoff will be the full thrust command given to the engines, and then at the counter, at the liftoff time, 0 time, it is actually liftoff. Everything is going, we got the 3-minute readiness signal, and everything is go for launch.
And I think also the tension is increasing in the auditorium there in the control center as it is here, I suppose.
Yes, it is. The room is full. There are quite about 50 journalists here. About 30 cameras are pointing in the control room. Everybody has left the seats and is standing up to watch on the center screen the rocket standing in Baikonur. We have 1 minute and 41 seconds and counting.
So maybe we use a few seconds to take a look at what is going on in orbit right now. The Saria module and the Unity module are in an altitude of approximately 350 kilometers, and of course the launch window is done in a way that the rocket can reach this. Okay, we don't have this video ready, so we just are standing by for this launch.
It is 1 minute and 1 second and counting. The last minute has started to go. 30 seconds and counting.
Я слышу интершум, там тишина? Да.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And we have liftoff. The first stage is in full power and everything is okay on the stage. It will burn for 126 seconds when we will have separation of the first stage.
Tank pressure normal.
Tank pressure is normal. The trajectory is as planned. And we will in a few minutes see here on the center screen the projection of the trajectory and the distance from the launch pad, the velocity and altitude. We're 80 seconds after liftoff. All systems are working normally. The telemetry system is okay. Data are received from the rocket. Trajectory okay. We're at 105 seconds after liftoff. 20 seconds to separation. 10 seconds to separation. We shall have separation. Separation has been confirmed. We see now the projection. On the map you see the ground track going from left to right. You see the trajectory. The dimensions are in kilometers. It's now at 62 kilometer height, and the range is about 104 kilometers. And far on the left side you see the orbital velocity, which is now 1,937 meters per second.
Systems okay and the engine also okay. Pressure
All systems on the second stage are okay. Engine pressure and everything is okay.
Main fairing separation confirmed.
The main fairing has been separated and it is confirmed. You see it on the screen. The service module is now fully visible, or should be fully visible on top of the rocket. 89-90 kilometer height and 270 kilometers. You see on the ground track a red shaded area, which is the impact area of the first stage. We'll later see another one, which is the impact area further to the right, which is the impact area of the fairing.
Engines working nominal.
Engines working nominal. Velocity approaching the 3,000 meters per second. 106 kilometers altitude. and range 315 kilometers.
Pressure, engines okay.
Pressure, engines, everything okay.
System nominal.
All systems are nominal. The second stage will burn for another about 100 seconds before the second stage is ignited.
Доброе утро. Пока все идет благополучно. 256 включилась и унесла с собой
30 seconds to separation of second stage. At an altitude, we're now at 127 kilometers. You see also on the countdown clock had switched to seconds, and it will continue to count just seconds after liftoff. It will not show hours and minutes. So we're at 3:43, so the second stage has been separated and has been ignited. So it is now the last stage, on top of which the service module is located. Engines also of the second stage are working normal. We have just got a message that we are receiving.
Jochen, thank you very much for the moment. I think that was really a great launch, and everything seems to be quite nominal. Now, ladies and gentlemen, as you know, on board the service module is also the first European experiment. And I have with me Mr. Huber from the Steinpais Transfer Center, who is responsible for this experiment. Now, Mr. Huber, I guess this is also a relief for you. And probably you can give us a little bit an idea what this experiment is about and when it will become operational.
Yes, of course. Maybe you all know these radio-controlled watches that always adjust the time according to the local time zone. But as soon as you travel to another country, the time zone is no longer correct. You have, for instance, a watch that has a dual display, and we want to overcome this limitation by creating a time signal that is transmitted from the space station to the ground, which will always adjust your watch to the local time. But moreover, our signal is coded in a special way, and we have different applications like turning off stolen cars by sending a signal to a key, or you could even turn off a stolen credit card.
How long would it take actually until such a signal would reach a certain point on Earth? Is that instantaneous, or does it take a certain delay?
Of course, we have only one space station so far, so in order to turn off a transmitter, we need to get a radio contact with the ground. So it can take 2 or 3 orbits before we have radio contact, but in case of a wristwatch or of a stolen car, you don't need immediate access.
I think there is another quite remarkable point about this experiment concerning commercialization of spaceflight, isn't it?
We want to offer this as a commercial service. The antenna is now already mounted on the service module. It's now in orbit. We have this antenna array with a serial beam. This electronic unit will be transferred with a progress module and installed by the cosmonauts within 6 months, and then we are operational, and we are planning to found a service company within 2 years.
Thank you very much, Mr. Huber, and good luck for this very important first European experiment.
You're welcome.
Thank you very much. As we are approaching now the orbital injection, Claudie, over to you.
Thanks, Thomas. We heard before the launch that the DMSR will also be used to control the docking of the ATV, the Automatic Transfer Vehicle. With me today, Patrice Amadieu, the ATV Project Manager. Could you give us some more information?
Yes, first thank you very much, and of course it's a great event for the space station overall, but also for the ATV, which hopefully will dock to the service module in a few years from now.
Yeah, maybe we can have at the same time the video.
Okay, yes, let's have a look to that. Okay.
No, please. Tell us some characteristic of the ATV, the mission.
The ATV itself is a vehicle which in fact will make automatic docking to the station. And therefore only after that will communicate with the data management system of the service module. The ATV is a 20.5 ton vehicle when it is fully loaded, about 10 meters high, 4.5 meters diameter, and with the solar arrays up to 20 meters tip to tip. So it's a quite big vehicle.
Launched by Ariane 5.
It will be launched by Ariane 5 Plus in end 203 or first part of 204. And it's worth to mention that recently the European Space Agency has signed a contract with Arianespace for 9 launches, which is therefore covering the 10 years of ATV operations and launches. And the ATV mission, to complete that, of course, will be not only to provide pressurized payload to the station for refurbishment, but also will make refuel to the FGB tanks, and also will contribute mainly to the reboost of the station in orbit, which is one of the main functions for the system and for the operating of the space station.
Thanks a lot. It's a nice project for Europe.
Thank you very much.
Well, ladies and gentlemen, I think in the meantime the service module has been injected into orbit, and let's just ask Jochen Graf at ZUP how things are going there. Jochen, give us a little update, please.
Okay, Thomas, we just had a big round of applause for the separation of the service module from the third stage. Now the automatic software on board executing in the DMSR computers is now performing the deployment of the mechanisms. The core system is being activated and deployed. The antennas are opening.
Okay, so everything is still nominal.
Now the solar arrays are starting to get deployed. We see an animation here on the main screen. The Regul antenna is also being deployed. The solar arrays are about halfway deployed. These are the largest solar arrays which have ever flown. And the last big deployment will be the antenna, the big Luch antenna on the back end of the service module, but that will only happen after the solar arrays are fully deployed. We're now at 12 minutes and 40 seconds after liftoff. And we will, in 18 minutes after liftoff, we'll have the first detailed telemetry data from the service module itself.
Thank you very much, Jochen, for the moment. We might come back to you just for the acquisition of signal. Now, as the service module is in orbit, maybe we take a little look into the future about the further assembly of the International Space Station. And again, we have prepared a little video that shows you in a short time how this assembly will continue. First, we take a little tour through the service module, which is now also floating like this in weightlessness in orbit. Here you see again the central control post. Still no people on board, but this will come in a few months. And as we are going outside this hatch into space, we see how the further assembly will take place. This big structure is more and more building up, and as it has been mentioned before, it takes approximately 40, even a little bit more flights to come to its final configuration. It's, I think, worth to mention that the European Space Agency is not only participating with this main part, at least from the financial volume, the Columbus module, but it is also involved in the production of more infrastructure, 2 nodes, the cupola, scientific hardware, and of course the the European robotic arm, which will be delivered on the SPP, which the service module will host. Okay, now as we are waiting for the acquisition of Signal, maybe we asked our director for some comments of these quite exciting pictures we have just seen. Mr. Feustel-Büchel, what are your feelings at this moment?
Of course, I'm excited and I'm pleased with the success. Swesda means star. I think one can say a new star is born. That is really a great achievement for our Russian friends, whom I would like to fully congratulate for their achievements. But it's also a great achievement for all of us, the space station community. And I think one very important element is now up in orbit. We are waiting for the acquisition signal.
Yes.
And in 2 weeks, as already heard, we are going to see the docking, hopefully with a great success, to the other elements of the space station. So we are ready to go. That's a real great day for all of us. And I hope we will continue in the same positive manner with the other elements to come.
Okay. Thank you very much, Mr. Feustel-Büchel. Now, the ATV, which has been mentioned before, will of course also carry a lot of payload to the International Space Station, which then will be used by the astronauts. And maybe we spend a few words on the European astronaut course, Claudie.
Yes, for the time being, in the European Astronaut Center, we're 16 astronauts. 10 of us are in duties in Houston, training for mission shuttle or ISS increment mission, and the other one in Europe, in ESTEC or in Köln, in ESC. So we can speak also a little bit about what kind of training and how long it will take to be ready.
I think the way to come to the space station for astronaut is quite a long one. The training basically is divided into 3 parts. You get a basic training where you learn all the basic things for becoming an astronaut. Then you get into an advanced training, which takes approximately 1.5 to 2 years, where you specifically get training of all the onboard systems of the Russian and the American segment, and of course the parts of the international partners, like, for example, the Columbus Laboratory. And finally, once you are assigned to a specific flight, a so-called increment, you get mission-specific training, which is depending, of course, on the contents of this mission and takes approximately 1 year, maybe slightly more. So overall, you can say it takes 3 years to get prepared for such a mission. And in the meantime, while you are waiting for these assignments, the European astronauts are working in technical jobs, either here at ESTEC or in Houston or at the European Astronaut Center. Okay, so I think this is a good moment to hear last time some information from the control center in Zug. Jochen, how are things developing there?
Do you hear me?
Yes, Jochen, we can hear you very well.
Everything is perfect here. I have with me Dr. Branitz, who is the avionics chief and our counterpart for the data management system. His people have designed all the software, which we have seen so perfectly operating. And we can ask him to say a few words to how he thinks about how it's going. Is this microphone working? Vladimir? Yes, you can say now something.
Okay. Now it is an exciting moment when service module begin operate in the space in automatical mode, controlled by our main computer system. And computer system begin operate before launch and provide existing sum of system inside when launch on orbit. And now they make the first action of deployment element of construction. And everything is working on the plan and successful. We are satisfied. We now are at the end of very long way of development, manufacturing, and preparing for the activity, testing. And I believe, and we believe, on the maybe more long way of operating in space.
Yes.
I believe so. Yeah.
Yeah,
Okay.
Thomas, we should now have telemetry data acquisition. We're just waiting to hear from the people downstairs that we have live telemetry data coming from the service module. Christian, can you check what the situation is on the telemetry data with our console people? Because that's the most important event now, that we hear that the service module is also communicating live with the ground. We have coverage now.
Now we have 1 minute up to the end of telemetry data acquisition.
Yeah. So
and,
one more.
and all the data is in such way that everything go on the plan as foreseen in our software.
Everything is
Control
normal.
center. I think the fact that we have now the acquisition of telemetry data is really showing that everything has been running nominal up to this point. And just before we end, let's have a last link to our control room up there. Roland, how are things in our control room here at ESTEC?
Yes, thank you, Thomas. We just start to receive the first bits of service module telemetry. Everything is working nominal according to what we see right now, but for sure we wait for the complete set of data. But from our perspective, everything works nominal, and we are very pleased with the launch of the service module.
Excellent. Thank you very much, Roland. Now, ladies and gentlemen, this basically concludes our presentation today. Thank you very much for attending this very important moment for the manned spaceflight in Europe and, of course, the manned spaceflight of the whole world. We thank you for getting up that early and enjoying with us the launch of the Swesda module.
Thanks a lot, Thomas. Congratulations. Au revoir. Bravo, Thomas.